The potentiometer in the base of my ProSisTel 71D rotator recently gave up the ghost, and so I don't have position indicator anymore. So I decided to come up with an alternative scheme. I really didn't want to go up on the tower and pull down that heavy rotator again, and I've always wanted an independent position indicator anyway. So I decided to come up with a scheme that uses Hall effect sensors, Hall effect switches, not the linear type, but the switch type. And I positioned or installed them in these two 3D printed cases I made. Now, these cases are a lot bigger than they really needed to be, but I had the room for them, and this made things a little simpler, so they're pretty large. They have oversized lids. The lid's actually on the bottom. And they're held down by magnets or they will be, to the steel plate that's already up there on the tower. I have a intermediate steel plate between the rotator plate and the top plate. And that's where these will go. And this can, you'll see, fastens down very securely with these magnets, which are rare earth magnets, about 1/2 inch in diameter and 1/8 of an inch thick. And once I have them down there, this is very secure. So now the Hall effect sensors are arrayed inside the case around the edge here. And there's 9 of them on this side, 9 of them on this side. And they have their own pull-up resistors and filter capacitors. They're very simple. It's a simple PC board. And there's a cable over here that connects these 9 sensors over to this side where they are aggregated together. And 16 of those sensors tie into a 16:1 multiplexer demultiplexer. It's the 74HC4067, and that handles 16 of the Hall effect switches, and then there's 2 others that come over here and are handled separately. Now over here on the Arduino, this is an Arduino Uno, and I'll clean this all up I'll put a different version of this in a box. And what the Arduino does is it sends a counter up on 4 address lines that come up to that 16:1 demultiplexer, and those 4 address lines give you 16 possibilities to select one of those 16 Hall effect sensors and decide whether or not it has been activated or not. And that feeds that back down on a single line back to the Arduino. The additional 2 Hall effect sensors come back on their own separate lines. So the Arduino just simply keeps counting up and essentially swings around the switches, the Hall effect switches, looking to see whether they have been activated or not. And I'll show you how that works. And then the Arduino takes the output and feeds it to this simple little, these are really inexpensive OLED displays, and tells me what the azimuth is. Now right now there's no Hall effect switch being activated, so it's telling me 0 and with a fault. But this is my mock-up, a simulation of what the mast would be looking like with the magnet positioned over these Hall effect sensors. And if I drop this down on here, you will see that suddenly I get a azimuth indication, and that will change as the mast rotates. This is roughly the 0 position, and it goes 10, 20, 30, I went past 40 too fast. 50, 60, and so forth, going around all the way. Now you notice that I'm getting essentially 36 readings out of 18 Hall effect switches, and that's because I have the software set to when the magnet is between two of the sensors and activates both of them, the software says, okay, I'm just going to average those two. I made sure that that would happen because I wanted one of the switches activated all of the time. Otherwise, if I get a dead spot, I don't really know where the antenna is pointing. So this rather cleanly gives me 36 position indicators every 10 degrees as we rotate around as the mast rotates. I did this because I didn't want any mechanical linkage to the mast. I just didn't trust it. This scheme has its own deficiency in that if I get snow or rain or something and it freezes up there, this will lock in place, and if the mast tries to rotate, it'll probably mess everything up on whatever I use to position the magnet. And by the way, I am going to be manually turning the rotator using simple pulse width modulator motor controller and a double pull double throw switch so that I can switch the polarity. So essentially I have an alternative to the original ProSisTel controller, which sells for several $100s, and this can all be put together for really peanuts. I'm going to try and get this up on the mast and clean up the microprocessor and the display, put it in a nice little box, and come up with a lot better system for connecting all the wires up. As I said, I really only need 9 wires going up to the tower, and I have that already in place. So